actually, just to illustrate that, is with these scraps of paper in front of you.
I just saw you on
What's that? What's that?
Oh, okay.
Oh yeah. So the little sheets in front of you. I want you to talk to the person sitting next to you, and I want you to. Well, first of all, right now, just tear this in half. Tear this piece of paper in half. Just once. Just once. Okay. Nice. Good tearing. Was that easy or hard to do? Easy. How easy? Yeah. All right. Cool. Cool. So, is there a way? I want you to talk to your partner. Is there a way that you could make it harder to tear without changing it? So it's still paper, but it's harder to tear. Talk to your partner. Talk to your partner. Let's see if we can find out the way to make it the hardest to tear.
Hold it like this for it to be like harder to tear. Take your I'm holding it. Not lifting it up.
I just want to guess it. I'm not going to
Yeah.
tell each other.
You're supposed to really write down the middle.
Yeah, try your idea out. Yeah. Okay, cool. So by show of hands, who thought about folding it up? Cool. Yeah, pretty much across the board. Anybody think of something different that you might do? Yeah.
Crumple it up.
You could crumple it up. That's a nice idea. Yeah, what else?
Or gummy bear.
Oh man, all right. So it's just the way that you handle it, right? You can actually just keep it on the table. It's harder to tear with your palms than holding it up and tearing it. So when you fold it, how much harder is it to tear? It's like a lot harder, right? When you fold like 4 or 5 times. What's that? Maybe twice as much.
Every time you fold it, it's twice as much.
Right, because you're talking about twice. But now, is it paper still? Have we done anything to change it from being paper? No, it's still paper, right? It'd be crazy if it were suddenly like steel. That'd be amazing, because we don't have superpowers. But no, it's paper. So what Ann Lynn was talking about is when we change the form of something, right? We still have the same building materials. We're still talking about just the same basic atoms here. But when we change the form, we can make it much harder and stronger. Which is the same reason that, so we have this, the graphite in your pencil lead and the diamond, they're still the same thing, they're just folded differently. What's that? Oh, they're around the corner.
Oh.
When we start changing the form of carbon, we can find out some really cool things and make some really cool new materials, including the strongest material known to man, which is pretty neat. Because
I just want to tell you guys one quick thing, and then you can talk about your favorite material ever. I know.
look at these cool models.
Alright, here's the thing about being a scientist. Because we work with things that are really small, we make models of things that are really big. So, we were talking about the structure. This is the structure of a diamond. I know, sometimes that happens to my models. So, if this is a carbon atom, and this is a carbon atom, see each of these junctures is a carbon atom. This is a really strong model of diamond, and you can see that each carbon atom is bonded to its buddy in multiple different directions. This is what graphite would look like. So it's bonded to its friends in this direction, but in this direction the bonds are a lot looser. They're all like, what? They're kind of holding hands but not very tightly. These guys are kind of handcuffed together, so super tightly. So when you draw with a pencil, so like let's pretend that this would be a gigantic, can you imagine how big this pencil would be? This is a gigantic pencil. So this is a giant pencil, and as we're moving our pencil across the paper, we're leaving sheets of this material behind. So I leave that one behind, and that's how we're making a mark. We're leaving sheets of carbon behind on our paper. All right, does that make sense? But here, we wouldn't leave a sheet of anything because it's so tight, and it can't come apart, which is why this is the hardest natural substance on Earth. But now Ben is going to tell you about, and I'm going to pass these around so you guys can see what they look like, and then just pass them into the back. But Ben's now going to talk about his favorite substance on Earth, that is... So, make the mark on your pencil, right? Emily was talking about that it's like these little sheets of carbon are coming off. Can you see them? If you draw like a really light
line of graphite, can you see those little, like what does it look like? If you look at if you draw a really light line, what does it look like?
Oh, did your pencil fail, honey?
It looks like dots.
Looks like dots, right? Does anybody else see dots?
Yeah.
Really faint line, you gotta look at it really up close. Oh man, going cross-eyed here for a second. Yeah.
Little things.
Looks like dots. So those are the sheets of graphite that are coming off. Now if you were to take those sheets of graphite and get them down to just one single atom layer thick, so thin we can't even see them, you get something that in model form looks like this. Now it doesn't look like much. Just kind of almost looks, I don't know, does it look like anything to anybody? Anybody recognize? Like
It looks like honeycomb.
honeycomb almost, right? Kind of like
Beehive.
beeswax. If you look inside a beehive. Yeah, there you go. You can hold it. That is the atomic model. So like Annalyn said, it's a model of what we call graphene. You guys want to say graphene? You guys want to say graphene like it's awesome? Graphene! Yeah, because it is awesome. It doesn't look like much, I'll admit. I'm going to actually take it back for you. But this is the strongest material known to humans. It is so strong that if you were to have a thread of this, now this is very small in real life. In fact, we're talking about something that is about a thousandth of the width of your hair, of a human hair. But if I were to take enough of this to make something that was as thick as your hair, it could hold 1,000 pounds. So a string of graphene that was as thick as your hair could hold something, could hold an elephant in the air. Yeah.
Well, how many of you, what is the Nobel Prize in Science?
It's prize given to the most brilliant invention or most peaceful invention or something.
Okay, it is the prize given every year to the most important scientific finding of that year. So, I can't remember, several years ago, they won for graphene, and right now we're going to do the experiment, close to the experiment that they did to win the Nobel Prize. So if you had done this for the first time, you would have won the Nobel Prize. Unfortunately, we're just copying, so we don't get to win the Nobel Prize. So what I want everybody to do is I want you to take your piece of paper, well,
Even if it's just a little piece of it,
you
that's
only
fine.
need a little piece, and I want you to color it really dark with your pencil. Don't break your pencil, but like color over it.
Yeah, go scribble
Just-
crazy.
Yeah, go scribble crazy. You have something like this, okay?